Our first video is going to be an introduction to functions. So for these videos, feel free to pause or you can even go faster if you find this stuff easy, if you've done it before. But definitely if you need to slow down, that's fine. If you need to pause and go back, that's fine. I highly recommend that you just do these at your own pace. So the first thing I want to talk about is what's called the difference quotient. And the difference quotient you're going to see written in many different ways in this class and in future math classes. So here I have it with an A and an H. Sometimes the A is replaced with an X. Sometimes the H is replaced with what's called a delta X. And you'll see, you don't need to write this down if you don't want to, but sometimes it's replaced with a delta X, which is, that delta is that little triangle, Greek letter. So you'll see this written in a bunch of different ways. You're actually going to also see it in your homework as written as the slope between 2 points. You might not quite recognize that, but when you get to one of there's two problems that have to do with difference quotients. One of them is like this. The other one that you're going to have is the same idea, but it's going to be the slope of a line. So we use difference quotients all the time in calculus. It comes up a lot. It's going to help us later on when we find what's called a derivative, which is going to be this estimate of the slope of a tangent line. You don't need to write that down now, but just kind of keep it at the back of your mind. It will come up later in a few weeks. Okay, so that's our first thing. You may have seen it last year. You may not. If not, that's fine. I'll show you how to do it. So let's go ahead and do an example. Okay, for our first example, we have f of x equals x squared plus 10x minus 4, and g of x equals 2x plus 1. I have four things I want you to find. I want you to find f of negative 2x. I want you to find negative f of h squared. I want you to find the composition between g and f. For those of you that don't remember this notation, this is the same as g of f of x. And I would also like you to find the difference quotient using the formula above. So please pause the video right now and do these problems. Okay, so we're back. If you didn't already do these problems, pause it. So I'm going to give you the answers. So if you got all these right, feel free to skip ahead, or you can skip ahead to any that you missed. I have a feeling many of you might need some help on the difference quotient. So I will show you how to do all four of these right now. So for question A, I have a feeling if you missed this, it was probably just minor math mistakes for the most part. You're basically just substituting in negative 2x for x. So make sure that you square the negative 2. That's going to give you 4x squared minus 20x minus 4. So for part B, we have two things going on. We are going to have a negative outside of our function, and every x that we have is going to be replaced with h squared. So in the end, you get negative h to the fourth minus 10h squared plus 4. I actually wrote it in the opposite order on the previous page. It really doesn't matter how you write it. On the AP test, basically all they really care about is that you have the right answer. Having it in standard form or whatever isn't going to make any difference. They'll give you full credit if you have the right answer, no matter what the form. So for part C, this is called a composition of functions. I hope that you've seen this before. So like I said, it is g of f of x. So we are going to be replacing f of x into our g function. And every x that we have in our g function, which is 2x plus 1, every x that we have in there is going to be replaced with this x squared plus 10x minus 4. And then we also have our plus 1. If you simplify it out, we get 2x squared plus 20x minus 8 plus 1, which gives us 2x squared plus 20x minus 7. So now we're going to do the difference quotient. And you might have noticed that I started a new slide for the difference quotient. The reason I did that is because there is a lot going on in this problem. There are two ways that people tend to do this. I don't really care which way you use. You can either split it into smaller parts, or you can just go ahead and plug everything in all at once. So I'll show you what I mean by that. So if you want to split it into smaller parts, you can start by doing f of a plus h and finding that. When you do that, you get a plus h squared plus 10 times a plus h minus 4. Then we'll find f of a separately. That is actually really easy. You're just going to plug in a for x. And if you want, on this step, you can simplify everything out. When you do that, don't forget to use the FOIL method. If you forgot to use the FOIL method, you probably missed this one. So you should end up, when you simplify this out, getting a squared plus 2ah plus h squared plus 10a plus 10h minus 4. So you'll notice this looks pretty bad. The good thing about the difference quotient, however, is that things tend to cancel out, assuming you do everything right. So I'm just going to write everything out. And then that is, so this part right here that I just wrote down, that is my f of a plus h. I'm going to next put in my f of a. I'll put that in right here, which we know is a squared plus 10a minus 4. You'll notice that I have that in parentheses. A lot of people forget to distribute that negative. Actually, if you forget to distribute that negative, the nice things that usually cancel out are not going to cancel out. So don't forget to do that. And this is all over h. By the way, just a reminder, when you're working problems out like this, don't work through the problem and skip putting the h in. You might lose points on the AP test on that, and I will definitely take off points for that if you do that in my class. So just please make sure that you're writing out the entire function here. Okay, so once we have that, you're going to find that a bunch of things cancel out. A squared and minus a squared are going to cancel. 10a, you'll notice that I have a minus here. That one's going to also cancel. My negative 4 and my plus 4, because remember I'm distributing the negative, are also going to cancel. If you do everything right, the second function should actually cancel there. So now I'm going to be left with 2ah plus h squared plus 10h all over h. So now the other thing on difference quotients is that your bottom h should also cancel out. So hopefully you got that to work. So in the end, you're going to get 2a plus h plus 10, and that actually is my answer. So now you can also do this problem by just writing out, you can like skip the intermediate step, and you can just write this entire thing out. If you were to do that, you would start it out this way. Actually, I usually do it this way. You would just write out this whole entire thing. Now, if you're prone to making a lot of careless errors, when you do math problems, you might want to skip doing it this way, because there are many places that you can make a mistake. So this one right here is the second method that you can use for this. If you are usually one of those people that works slowly and doesn't make a lot of careless errors, then you might be fine doing it this way. The last thing I would like to review regarding functions are even and odd functions. So I'll give you the definition. The basic definition of an even function is that a function is even if f of negative x equals f of x. These are going to be functions that are symmetric over the y-axis. So I'll give you some examples. You might even be able to start thinking of a few. So first example of an even function is f of x equals x to the fourth plus x squared plus 3. You'll actually notice for even functions, by the way, if it's a polynomial, all of the exponents are going to be even. You can kind of think of the 3 as being times x to the 0th, so the exponent of that would be 0. To prove that it's even, if you were to substitute in a negative x, we would know that that actually is the same as if you didn't substitute in that negative at all, because if you have a negative to the fourth or squared, it just becomes a positive. So that's going to be equal to what you started with. I'll give you also some visual examples. So some other examples are f of x equals x squared. F of x equals cosine x is an even function, and if you have any anything with an absolute value where the vertex of the absolute value, actually this is the same as with a parabola. If your vertex is on the y-axis, it will be symmetric over the y-axis, which means it's an even function. So the next thing that we have are odd functions. So our odd functions, what happens is if you substitute in the opposite of your x value, your y value is going to be the opposite. So actually, I didn't mention this for the first one, but just a little example, if something like, for even function, if you have like 2, 3 on your graph, then negative 2, 3 is also on your graph. You don't need to write that down unless you write an explanation as to why, but that's just what an even function is going to be. With an odd function, that would be if you had something like 2, 3 on your graph. That would mean that you would also have negative 3. So that's the difference between the two. So an odd function is going to be symmetric over the origin. And based on what you had with even functions, you might be able to guess that if you have a function that has all odd exponents, it will be an odd function. Actually, if you have a constant in here, it's not going to work. But this example that we have right here, if you were to substitute in a negative value for your x, what would happen is that a negative to the third is still going to be a negative. Negative times a negative here is a positive. Actually, what you might notice is that everything from the initial function changed signs. So this is the exact opposite of your starting function. And I'll give you some visual examples. So f of x equals negative x is an example. If you have y equals sine of x, sine is another great example of an odd function. So this stuff is going to come up later. You'll actually knowing which functions are odd and even is going to be really helpful in the future. So you definitely will want to write this down in your notes so you can refer back to it later.